This is Mrs. Spy, and this is my third video on Unit 1 Functions, Part 3, Domain and Range. Let's begin. Okay, so Unit 1, Video 3, Domain and Range. We'll also discuss in this function the difference between a discrete and continuous function. So some definitions. Domain is all the possible input values to relation and otherwise known as the x values. The range are all the possible output values to relation and the y values. Discrete relation only decides certain point values. Continuous function, a function relation is defined for all values over a certain interval. So right here is a discrete function. Looks like a scatter plot. That's my discrete function. And this one on the bottom, it's a continuous function that is defined between 2 and 5. Every single value. And we could think of it this way. I could sort of travel along the line. Here I have to go boom, 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 boom. I'm jumping. Okay. There are different ways to represent your answer. Answers with list, explicit notation, max-min notation, interval notation, septal notation. And throughout the video, I'll use each one of the notations and explain them as they come up. So let's start looking at the domain and range. Basic example. Discrete. Given the following points, 1, 2, 2, 5, 3, 4, 4, 5. What is the domain and range? There's a list. So we want to look at what the domain is. So first, the domain is all the input values of the x. The domain is 1, 2, 3, 4. The range, continue writing it as a list. We just list out the numbers. Be 2, 4, 5. Put the numbers in order and avoid repeats. The order doesn't matter, but teachers prefer it, and that's the way usually you'll see the answer in a multiple choice. Let's go on to the next one. Given the following function, f of x equals x to the third power plus 2, find the range of the following domain. So you substitute in each value. So you first find negative 3, negative 3 to the third power plus 2, which would be negative 27. Plus 2, which is negative 25. Then you find f at 2, negative 2 which would be negative 2 to the third power, plus 2, which is negative 8, plus 2, which is negative 6. Then you find f at negative 1, which is negative 1 cubed, which equals negative 1, plus 2, which is 1. And finally, f at 0, which would be 0 to the third power, plus 2, equals 0 plus 2, which is 2. And you write out your list, negative 25, negative 6, 1, and 2, and label it with the word range. Let's go on to the next problem. Find the domain and range to this graph by saying the maximum and minimum value. Put your answer in separate notation. So you first write the domain. Over here, the range. Over here, my min value, my max value, my min value, my max value. My minimum number here is 0. My max number here is 5. So in step builder, that would be 0. Sorry, what's that? That would be x, defined as x between 0 and 5. And the way you write it, it's like this: 0 less than or equal to x less than or equal to 5. Min-max notation, we don't know the less than or equal to is very well. The range, the minimum is 2, the max is 7, and that's y defined as between 2 and 7. Okay. Let's go to the next one. Find the domain and range, not orange, and range for the following quadratic function and write your answers in interval and explicit. So we're assuming these go on forever. So my domain is from negative infinity to positive infinity. Is an interval or explicit notation, just write all real numbers. you could write this fancy R for all real numbers. You put a line behind the R and you make a fancy R. That's domain. The range starts with the lowest value, which is approximately -2, and it goes all the way up to infinity. So the range would also be x, sorry, not x, because the range is y. So that'd be not x, but y greater than or equal to -2. Okay. I'm a domain, the following function h at x equals 3x 2x plus 9. So if you have a rational function, the basic idea is you can't divide by 0. So you set the denominator equal to 0, and you solve for x. So -9 from both sides, 2x equals -9, divide by 2, divide by 2, x equals -9 over 2. So our domain is x cannot equal -9 over 2. Be careful when you write the domain, you write not equals. On to the next one. Square root functions. You want to show that there's not that inside the radicand, the part inside the radical, is not less than 0. So you do 3x minus 1 has to be greater than or equal to 0. Solve for x plus 1 plus 1. So 3x has to be greater than 0. Divide by 3. Divide by 3. X has to be greater than 0. So x has to be greater than or equal to 0. Actually, in this case, it has to be greater than 0, not even equal to 0. Sorry, no, 1/3, not 0. Be 1/3. Oops, not 0, but 1/3. Greater than or equal to 1/3. X has to be greater than, so x has to be greater than or equal to 1/3. That is your domain in explicit notation. Be careful in Q. Sometimes when you solve your inequality, like 9 minus 5, x greater than 0, and you minus 9, in the next step, when you have -5x greater than -9, you will have to divide by a negative number, in this case, -5. Anytime you divide by a negative number, that changes our sign, so x has to be less than or equal to 9/5 in the second case. Let's go on to the next question. Rules of inequalities and more interval notation. When solving an inequality, if you multiply or divide by a negative, the direction of the sign changes the direction. So if it was less than, it becomes greater than. A and B as in parentheses as interval means all numbers in between A and B, but not including A and B. If they're brackets, as an interval means all the numbers between A and B, including A and B. If one's a bracket and one's not, as an interval, this means all numbers between A and B, but not including A, but including B. When using infinity, an interval always uses, for example, including 11, but not including infinity, or not including -3 and 5. You never put an including symbol next to infinity. Okay? So remember, be careful about square roots, be careful about rational, and these basic rules. One following example left, a word problem. Sally is saving money to buy a new pair of shoes. She already saved up $12. She set aside 50 cents a day. Given the function s at d equaling 12 plus 50d, explain why d cannot equal 12.5. Well, we're only working with whole days. So the domain of d is whole numbers. And last question, explain why S of D cannot be 17.25 or $8. Well, it can't be 17.25 since it is not a multiple of 50 cents, and Sally's making 50 cents per day, or saving 50 cents per day. So 0.25. And why is $8 not part of a range? Is because she's starting with $12. She is starting, Sally, with $12, and $8 is less than $12. So you're not looking at when she had less than $12. Okay? Hope that was helpful. If you enjoyed this video and you're waiting for more videos on Unit 1, which we posted today and tomorrow, please subscribe to this channel. And this was a video based on the in-class lesson of day 3 and day 10. The next video will be on function operations. This was Mrs. Spy. Hope you enjoyed this video. Posting it later today. Also, the next video will be on function operations, and then there's 4, including that one, there's 4 more videos to this total unit, making 7 or 8 videos in this first unit. Hope to see you online. Please subscribe to my channel. Please like if you like it, and spread the name of my channel. Thank you. Have a great day.